When first responders arrive at a new environment after a disaster, they're working with limited information. In order to help people, they need to be able to rapidly map areas after disasters. What if an autonomous system could help first responders stay safe and work efficiently? That's what we built. Our system pairs an unmanned aerial vehicle with an unmanned ground vehicle. The UAV launches, flies over the area, and captures aerial imagery to build a map. It then returns to land on the UGV to recharge. From that map, we detect obstacles and create a safe, traversable path which the rover follows autonomously. And because the drone recharges on the rover itself, this cycle can repeat, enabling rapid mapping of large areas. On the air side, our UAV carries a camera for image capture, an ESP32 microcontroller for handling communication, and a charging circuit that interfaces directly with the rover. On the ground side, the UGV has multiple large capacity batteries and a charging station to keep the drone charged, which enables long range operations. Both vehicles share some common architecture, an RTK GPS module for position fix. We'll talk more about this in a moment. A flight controller for control, and a telemetry radio for communication. RTK GPS is critical here. Standard GPS gives you meter level accuracy at best. RTK brings that down to centimeters, which is what makes our vision based mapping reliable enough to actually navigate from. Once the drone completes its survey, we have a set of images with a location of where each one was taken. The pictures are taken with about 75% overlap to ensure full coverage. We then project the images onto the field in where we think they should be. We then run a feature mapping algorithm to align the images with each other, stitching them into one single geolocated image. From that image, we run obstacle detection using computer vision. Any detection gets flagged as an occupied cell. We then plan a path through the grid to avoid obstacles, then simplify the path to cut down on unnecessary waypoints. Throughout our project, we validated every stage of this challenge. Our mapping tests have covered thousands of square meters with centimeter level accuracy thanks to RTK GPS. The full processing chain, from aerial capture through obstacle detection to path generation, has been demonstrated, matching or exceeding the requirements set out at the start of the project. The techniques we have developed have applications well beyond disaster response or search and rescue, from agriculture to infrastructure inspection and environmental monitoring. Thank you for watching.